So in the previous class, we completed the beta distribution of the first kind, right? Examples we completed all the examples they will give the mean and mode. So we need to find the probability function of the distribution. So coming to the beta distribution of the second kind, so there is a formula, PDF formula probability density function, right? So we have a probability density function as f of x is equals to 1 by beta of a comma b into x power a minus 1 by 1 plus x power a plus b for x greater than or equals to 0 and a greater than 0 and b greater than 0, b greater than 0. So these are the conditions for probability density function of the beta distribution of the second kind. So if this does not work out, so this intervals are not work out, that means x is not greater than or equals to 0, or a is not greater than 0, or b is not greater than 0. So then we can simply say f of x is equals to f of x is equals to what? Equals to 0. F of x is equals to 0. So what happens, they are saying y is equals to 1 by 1 plus x. So in the place of 1 plus x, we need to take what? We need to take y. So what happens then? F of x is equals to 1 by beta of, sorry, a comma b into, so they are saying 1 by x, 1 plus x, 1 by 1 plus x is written by y, right? So first this will become y of a plus b into, so we have x power, it means 1 by x by 1, right? So we can write it as what? So let me clear it and write properly. So what they are saying? So they are saying y is equals to 1 by 1 plus x. So this can be written as how? F of x is equals to 1 by beta of a comma b into y of a plus b into x by 1, right? 1 by x is 1 plus x is what? This is different. So this can be written as 1 minus x, 1 minus y into a minus 1. So this can be written like this. So I think we already completed the first example of this. First examples. Let me recall this. So they will give the mean and variance. They'll give mean as 1 and variance is equals to 2. So the find the parameters. They are asking parameters. So what are the parameters? A and B are the parameters, right? We need to find the values of the A and B. So mean is equals to what? Mean is equals to A by B minus 1. A is equal A by B minus 1. So from this equals to, what they are saying is equals to 1. So from this we'll find out A is equals to something or B is equals to something. So from that, again from the variance, we will conclude this. Like in the place of A or B, we'll substitute the like what we get in the mean value. So we will substitute it, then we'll get A and B values. So later what they're asking us to write the probability function. So what we need to do, we need to substitute this A and B values here. So what this becomes, f of x is equals to 1 by beta of 2 comma 3 into x power, x power a means what? A is 2, 2 minus 1, 1 by 1 plus x per 5. So what this becomes? So 1 by beta of 2 comma 3 into x by 1 plus x whole power 5. So this is the thing we'll get as a probability density function. See, we got the same answer, right? So 1 by f of x is equals to 1 by beta of 2 comma 3 into x power 2 minus 1 by 1 plus x whole power 5, where x is greater than or equals to 0. We'll not take less than 0. So next, coming to the another example. So second example. So what is the second example? For the beta distribution of the second kind, the mean and mode are, they gave mean and mode. So what are the mean? Mean is equals to 2 by 3 they gave. And mode is equals to what? Mode is equals to 1 by 5. Then they are asking to find out the probability function of the distribution. So same formula we'll use. We will use and we'll do once. Okay. Yeah. So what is the mean formula? Mean is a by b minus 1 is equals to what they are saying? 2 by 3. So I want anything. You can take a equals to something or b is equals to something. So what happens is this. So a is equals to, or else 3a is equals to 2 into b minus 1. So 3a is equals to 2b minus 2. So what happens, this comes this side, 3a plus 2 equals to 2b. So b is equals to what? B is equals to 3a plus 2 by. So this is the b we are concluding from this equation. So what we got? We got 3a plus 2. B. So from what is the variance? They gave variance, they gave mode. So what is the formula of mode? The mode is equals to what? Mode is equals to a minus 1 by b plus 1. So in the place of b, we need to substitute this. So I'm substituting it. So a minus 1 by, what is b? B is 3a plus 2 by 2 plus 1. They are saying equals to 1 by 5. So first we need to take LCM for this. So this becomes a minus 1 by 3a plus 2, and this becomes 1, right? So plus 2 by 2 equals to 1 by 5. So this becomes a minus 1 by 3a plus 4, and these two comes upward, right? Equals to 1 by 5. Okay, let me erase it. Yeah. Hmm. So what we need to do? We need to do cross multiplication. This becomes what? 5 to the 10. 10 into a minus 1. And this becomes what? 3a plus 4. So 10a minus 10 equals to 3a plus 4. So I am like taking a is one side and numericals one side. So this is what? This is 10a. So 10a plus this comes this side minus 3a equals to this minus 10 comes goes that side. So this becomes plus 10 plus 4. So 10 minus 3 is 7a equals to 14. So a is equals to what? A is equals to 2. A is equals to 2. So now you got the a value. What you need to do? You need to find out the b value now. So how we will find out? We will substitute that value here. Equation 1, or else in the mean also you can substitute. So a minus 1 by b plus 1 equals to 1 by 5. So a minus 1. So how much a we got? 2. 2 minus 1 by b plus 1 is equals to 1.1 by 5. So cross multiplication. So 2 minus 1 is 1. So 5 goes that side. 5 is equals to, and this b plus 1 comes this side, b plus 1. So 1 goes that side, it becomes minus. So b is equals to 5 minus 1, which is equals to 4. B is equals to 4. So we got a value as 2 and b value as 4. So what we need to do now? We need to find out the functions, like probability functions. What is the formula? So first you need to remember this. F of x is equals to 1 by beta of a comma b x power a minus 1 by sorry 1 plus x whole power a plus b. So this is the formula. So we got the a and b values right. We need to substitute that values here. So f of x equals to what? F of x is equals to 1 by beta of 2 comma 4. We got 2 comma 4, which is into x power a minus 1. So what is a value? Value is 2. 2 minus 1 is 2 minus 1 by 1. You can write 1 also. So x 1 plus x. A plus b. A plus b. What is a plus b? 2 plus 4. 2 plus 4 is 6. So this is the required probability function. Required probability function. So where we can say x is greater than or equals to 0. X is greater than or equals to 0. So this is a second problem. Like all the things are same process, but in the first one they give mean and variance. In the second question they gave mean and mode. In the third question also it is similar question only, but in the third question they give mean as well as harmonic mean both. So the just the formula differs, but the process is same. So we will do. Sorry. Yeah. Mean is equals to what? Mean is equals to 3 by 4. And harmonic mean is equals to what? Harmonic mean is equals to 2 by 5. So they are asking parameters, A and B values you need to find out. Then they are asking the PDF also, PDF function also. This you need to find out and this you need to find out. You know mean formula. What is mean formula? Mean is A by B minus 1 is equals to, how much they give? They give 3 by 4. 3 by 4. So we can take anything. So 4A is equals to 3B minus 1. So 4A my plus 1 is equals to, I mean to say, this is 3, right? B minus 1 into 3 is 3B minus 3. So this becomes 3 equals to 3B. So 4A plus 3 by 3 equals to B. So this is the B value. Or else you can, from this, you can find out the like A value also. From this, what will be the A value? A is equals to 3B minus 3 by 4. So this you can substitute in the place of A, or this you can substitute. Anything you can substitute. The answer will be same. So they substituted the B. B is equals to 4A plus 3 by 3. Coming. So what is the harmonic mean then? What is the formula of the harmonic mean? So the formula of the harmonic mean is what? Harmonic mean is equals to A minus 1 by B. They are saying what is harmonic mean in the previous one? They said 2 by 5. So what we need to do? So we will substitute, like here only we can substitute B value, or else A value we can substitute. So what is B value? First, let me simplify cross multiplication, then we'll do. So 5 into A minus 1 equals to 2B. This becomes what? 5A minus 5 equals to 2B. What is B value? We can say 4A plus 3 by 3. Okay, 3 by 3. So what this happens actually? So this becomes 5a minus 5 equals to 8a plus 3 2s are 6 and by 3. 8a plus 6 by 3. So this 3 comes this side, left hand side. This becomes 15a and 3 into 5a minus 3 into 5. 8a plus 6 is equals to 6. So what? 15 minus 8 is what? 7a is equals to how much? 15 plus 6 is 21. So 21. So a is equals to what? A is equals to 3 you got. A is equals to 3 you got. So now we will substitute here. So a value here. So what is the a value? 1 a minus 1 by b is equals to 2 by 5. So a value is 3. We will substitute 3 here. 3 minus 1 by b is equals to 2 by 5. So 3 minus 1 is what? 2. 2 by b is equals to 2 by 5. So this 2 cancel. 1 by b is equals to 1 by 5. And when we reciprocal, b is equals to how much? B is equals to 5. We got a and b values here. So what is a function now? So f of x is equals to what? F of x is equals to 1 by beta of a comma b x power a minus 1 by 1 plus x a plus b and x greater than or equals to 0. So in the place of a and b, we need to substitute the values we got. So f of x is equals to what? F of x is equals to 1 by beta of 3 comma 5 into x power 3 minus 1 by 1 plus 6. A plus b means what? 3 plus 5 is 8. So which is x is greater than or equals to 0. Or else we can say f of x is equals to 0. F of x is equals to 0. This is the process. Next, check your progress. You can do the same process. They gave the mean variance in same two questions. So from that, you need to find out the parameters they're asking. They're not asking the probability density function. They're asking only the parameters. So they gave the questions also, exercise questions also. If time permits, we'll do the exercise questions also. And then we'll start the Cauchy distribution. Okay. Now we'll start the Cauchy distribution. Cauchy distribution. So applications of the Cauchy distribution. So first we will see what are the objectives first. So what are the objectives we can see? So first objective after reading this unit, you should means we should be able to know the situation where Cauchy distribution is applied, like where we are using the Cauchy distribution, we'll see. And to learn the method of fitting the Cauchy distribution also, we will see. So what are the two objectives we can find in this unit? So applications of the Cauchy distribution So we can find the where the situations the Cauchy distribution is applied and how to fit the Cauchy distribution also. We will see both the things will cover here. So coming to the introduction part. So in the 60th unit of the block 2, we study the theoretical aspects of the Cauchy distribution. In this unit, we learn about the situations where the distribution is used and also the procedure of fitting the distribution. So what is the objective? Then the introduction is same. So here we will see the how the distribution is used and the what is the procedure we will use to fit the distribution to the given data. Coming to the Cauchy distributions, named after Augustin Cauchy, this continuous distribution is also known as Lorentzian distribution. In quantum mechanics, it is used to model the distribution of the energy in unstable state. It is a popular distribution in robustness studies. So, it is used in the modeling for polar and non-polar liquids and the porous glasses. So, in spectroscopy, the Cauchy distribution describes the shape of the spectral lines. In hydrology, it is applied to extreme events such as annual maximum one-day rainfall and the river discharges. So it is a distribution of the observations for the objects that are spinning. It is used in the physical anthropology in measurement for results. So where we are using these are the things in this if you read this, so you'll understand where we are using the Cauchy distribution. So in the physics anthropology we are using, or else in hydrology we are using, in spectroscopy we are using, so everywhere we are using actually. So coming to the examples of this, what is the first example? In the first example, in a Cauchy distribution, the values of the medium of the quartile deviations are 56.20 and 8.26 respectively. So they are asking what median is equals to 56.20 and quartile deviation is what? Quantile deviation is 8.26 respectively. They are saying find the probability function of the distribution. So we need to find the probability density function of the distribution. So location, we have two like parameters in the Cauchy distribution, right? So what are the two parameters? Location parameter and scale parameter. So location parameter what? Theta. And scale parameter is lambda. So these are the two. So location parameter equals to median, that is 56.20, and scale parameter is what? Lambda, that is quartile deviation, that is 8.26. So what is the function of the Cauchy distributions? In the previous classes we studied, right? What is the function? The function of the Cauchy distribution is f of x equals to 1 by pi into lambda by lambda square plus x minus theta whole square. So where minus infinity to less than x less than infinity are the intervals. So f of x is equals to 0. These are the actually the probability density function, right? So here we'll substitute the values. We have the lambda value as well as the theta value, right? We'll substitute the values here. So, So f of x is equals to what? F of x is equals to 1 by pi. Uh, Lambda, what is the lambda value? In the previous one, we can say lambda value is 8.26 by, what is lambda square? Lambda square is, so what is lambda square? Lambda square is 8.26 whole square plus x minus theta. X minus theta is, x is what? X only, minus theta is 56.20 whole square. So the same thing we wrote here. See, this is the probability density function. This is the probability density function. This is the probability density function. Next, coming to the other example. So next, coming to the second example. So what is the second example? For the data given in the following frequency distribution, fit a Cauchy distribution, then expected frequencies. They are asking the expected frequencies we need to find out. So what we need to take? They gave the class interval as well as the frequencies also, class intervals as well as the frequencies. They gave class intervals from 0 to 15, 15 to 30, 30 to 45, 45 to 60, 60 to 75, 75 to 90, 90 to 105, 105 to 120, 120 to 35. So respectively, they gave the frequencies for the class intervals also. So now what we need to find? We need to find the, what we need to find? We need to find the expected frequencies, right? From the frequency distribution, it fitting the Cauchy distribution. So from this, we need to find the expected frequencies. So first, what we need to do? We need to do LCM first. So how to do LCM? How to do LCM? So two, first two, we will write two like that only. Next from that, we will add 2 plus this 3 equals to 5. Then 5 plus 4, 9. This cross it will be. Actually, let me explain it once again. So 2 will be same. Then 2 plus 3 equals to 5. 5 plus 4 equals to 9. 9 plus 360 is 361. And 369 plus 122 is 491. 491 plus 3 equals to 494. 494 plus 4, 498. 498 plus 1, 499. 499 plus 1 is 500. So the sum of the frequencies as the last number of the uh, least common factor LCF least is also same. So now what we need to do? So n by 4 we are taking. N by 4 we are taking. So what n by 4 if we take, so what is the value we are getting? N by 4. Then n by 4 is equals to what? 4 quartile, right? So n by 4 if we are taking, that is 1 by 25. Means what is n? N is 500. So 500 by 4 is 125. And n by 2 is 500 by 2 is 250. And 3n by 4 is what? 3n by 4 is 3 into 500 by 4. 3 into 500 means 1500. 1500 by 4 is equals to what? Is equals to 3, 375. So 3n by 4 is equals to 375. Sorry. So first we need to find the Q1. Q1. So for finding the Q1, so first we need to mark in the previous table. So what is Q1? Q1 and Q2 are the 369. And what is Q3? Q3 is 491. So L1 will become 45 for the Q1 and Q2. And for the Q3, it becomes 60. 360 and 122 frequencies. So coming to here, so what we are doing, so from this we will find out the formula for Q1. So we have the Q1 formula. From the derived one, we will find out Q1 is equals to what? Q1 is equals to 45. 45 is L, lower boundary, plus what is 125? 125 is N by 3 we are doing. N by 3 minus 9. 9 also we'll see by 360 into 15 into 15. So what is 9 and what is 350? We'll see. So 9 and 350 are what? So 9 is the previous CF. 360 is the F1. So CF minus F. CF F we are taking. So CF and F value we are taking. So this is, let me write. Sorry. See, from the Q1 we can write it as Q1 equals to lower boundary plus N by 3 minus CF by F into H. H means height equals to, if we substitute the N by 3 is 125. Lower boundary for the Q1 is 45 and CF value is 9. So by F value is 360 and H value is 50. So we will find the Q1 as as well as the Q2 also we will find out. Q2 is what? Q2 is 45 plus 250 is the N by 2 minus 9 by 360 is the F into 15. Then if we calculate, we'll get the same answer only. Don't confuse. So 45 plus 250 minus 9 is what? 250 minus 9 is 241 by 360 into 15. So you can cancel here actually. 5 threes are 5, 7 are 35, 1, 2s are 72. So 72. So 3 ones are 3 twos are 6 and 1 remaining. And we can say 3 fours are 24. So 241, it becomes 45 plus 241 by 24. We can simplify this directly or else we can do LCM with this and we can divide them from the whole 24. For the Q3 also we find out same 60 plus 375 minus 360 into 15 by 122. So this whole, if we calculate 375 minus 360, that is what? It is 15, right? 15 into 15. So this is what? This, if we calculate this, we'll get 1.8443. 1.8443. So what is the, this one? 60. 60 plus 1.60 plus 1.8443. This becomes 61.844. Now what we need to find out? We need to find out the estimate of the location parameter. So estimate of the location parameter is what? Q2 means Q2 is 55.0417 because it is nearer value, right? 55 is the, then scale parameter is what? 6.0055. What is the, how we will find the scale parameter? Scale parameter is equals to lambda is equals to Q3 minus Q1 by 2. What is Q3 value? 61.8443 minus Q1 is how? 49.8333. By 2, if we calculate, we will get the same value. I'm sorry. So what value we got? We got 6.0055. 6.0055. So the probability density function Cauchy distributions to be fitted is, so what is the Cauchy distribution function? Probability density function. So probability density function is what? F of x equals to 1 by lambda. So what is the 1 by pi, sorry. Lambda value is what? Lambda value is 6.0055 by 6 lambda square 6.0055 whole square plus x minus, what is theta? Theta is 55.0417 whole square, where we can say minus infinity less than x less than infinity. Otherwise, we can say it is f of x is equals to 0. This is about the second example. So they are saying, see, you can see in the table. So from they gave ci lower limit z is equals to f of t value f of t and uh, delta f of z value and expected values also. And for this they're preparing a table. See, from that they become a table. So they gave this table, actually the question that did not mention. Okay, this is the table they gave. From this, what they are taking ci values, observed frequencies as the expected frequencies. Expected frequencies, like expected frequency is 17.3, right? So which is similar, nearer to the 17 only. So we'll take 17. So like that we can take. So what is observed less than 0 means we can take 0. So 0 to 15 is 2. So like that. that- So we have anything? See, 0. And 0 to 15? 0. 15. So coming to the third example. So with the Cauchy distribution of the following data and obtain the expected frequencies. So what is the class interval? CI is what? Class intervals is what? 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. For 0 to 10, it is 2, 10 to 20, it is 3, and 20 to 30 is 332, 30 to 40 is 150, 40 to 50 is 7, 50 to 60 is 4, and 60 to 70 is 5. So the total frequencies is equals to 500. So So these are the frequencies, right? So two, three frequencies. So we will need to find out the LPF. So how we will find the least LCF? So 2 will be said, then 2 plus 3, 5, 5 plus 332, 337, 337 plus 150, 487, 487 plus 7 is 494, 494 plus 4 is 498, 498 plus 2 is 500. So from here only we are taking what is the 10. 10 is the H. H is equals to 10. Then Q1 is what? Q1 and Q2 is equals to 337 only. And Q3 is equals to what? Q3 is 487. So for the Q1, what is the L value? L value is 20. L is equals to, let me write it clear. So Q1 and Q2 equals to what? 337. So for this, L value is what? L value is 20. And F value is what? F value is 332. దాని సమానంగా ఉన్నది that is F value. And LCF value is, CF value is what? CF is equals to 5. The above value of above value. So this is about H is equals to 10 only. So this is about Q1 and Q2. So let's see for the Q3. Q3 is equals to what? 487. So 30 to 40. 30 is the lowest. L is equals to 30. H is equals to 10. And then F is equals to 150. Uh, and CF is equals to 330. Okay. So first we need to find out the n by 4. So n by 4 is what? 125. I mean to say n by 500 by, actually this is 3, not 4, I think so. 3, we'll see from 3. 3 ones are 3 ones are 2, and 20, and 6, it's not coming. It's 4 only with n 500 only, n value. Yeah, n value is 500 only. So 500 by 4, I thought, okay. Ones are 1, twos are 2, then 5. 125. So n by 2, 250. So n by 2 is 500 by 2 is equals to 250. Then 3n by 4. 3n by 4 is equals to 375. So 3n into 500 by 4. 500 by 4 is 125. 125 into 3 is what? 57. 375. Next, coming to find out the Q1, Q2, and Q3. So Q1 is equals to how much? Q1 is equals to, lower limit is already told, 20 plus what is n by 4? 125 minus, so I told CF. CF is 5 only by 332 into 10. So the Q2, 20 plus 250 minus 5 into 10 by 332. So if you calculate all these values, you'll get the correct exact value what they give. So Q3 is equals to what? Q3 is equals to 30 plus 375 minus 332 by 150 into 10. So which is equals to 32.8667. 32.8667. Now, what is the median value? Median is equals to what? Median is equals to 27. Theta is equals to 27.3795. 3795. Then lambda value is what? Lambda is equals to quartile deviation. So Q3 into Q1 by 2. So what is Q3 value? Q3 is 32.8667 into Q1. Q1 is 23.6145 divided by how much? Divided by 2. Divided by 2. So if we calculate 32.8667 by into 23.61445 and divided by 2, then we'll get what the value? We'll get Q3 into Q1 by 2 is equals to 4.6261. 6261. So what is the probability function of the Cauchy distribution they're asking? So we need to find the probability distribution, like density function, PDF function, probability function. So f of x is equals to, what is the formula actually? F of x is equals to 1 by pi into lambda by lambda square plus x minus theta whole square. So f of x is equals to what? 1 by pi. What is lambda value? Lambda value is 4.6261 by 4.6261 whole square plus X minus theta is how much? 27.3795 whole square. So where the parameters are, like I mean to say intervals are minus infinity, less than x, and less than infinity. So x is having the intervals of minus infinity to the infinity. So, and 0 otherwise. This is the probability function of the Cauchy distribution. Again, we have a table 0 less than table. So here we can see CI class intervals less than 0 means lower limit will be minus infinity to the, and Z is also minus infinity, and f of x if we do, that is also 0. So when we take class intervals from 0 to 10, then the lower limit becomes 0. We know for the CI, lower limit is 10, for this 20, 30, 40, 50, 60, and 70 only. This no. So T minus theta by lambda values they give, Z values they give. From that, f of Z values, lambda Z, delta Z, f of Z, and expected values also, frequencies also. So from this, so we know uh, the shown in the following tables are less than 0, then observed frequencies are 0, and less than 10 there are 2, and 10 to 20 is 3, 20 to 30 is 332, 30 to 40 is 150, 40 to 50 is 7, 50 to 60 is 4, 60 to 70 is 2, less than 70 that is 0, 500 total we will have. So expected frequencies also we are finding, expected frequency formula also we have. So from that formula we are finding the f of expected frequencies. 26.65 we got. So 26.65 is similar, like nearer to 27. So from 0 to 10 we got 14.75, which is similar to 15. So 10 to 20 we got 48, and 47.70, so which is nearer to the 48. So we will take 48. So 20 to 30 we got 242.95, so which is approximately to 243, so we will take 243. So 30 to 40 we have 112.05, so which is equals to 112. Then 40 to 50 we have 23.8 expected frequency, that is equals to 24, and 50 to 60 we have 9.7, which is approximately to the 10. So 60 to 70 we have 5.2, which is nearer to the 5 only, so we will take 5. If it is 0.5, it is 0.5 or above the 0.5, we'll take the next number, or else we'll take the previous number only. So less than greater than or equals to 70, then we are taking 17.2, which is equals to the 17. So it is equals to the 50. So these are the exercise sums are there. So in the next class, we will do the applications exercise sums also. Any sums we have, we will do that example sums. And if you have any doubts, you can ask me. So Kochi is also completed. So once again, we will do the exercise sums of all the applications sums. Thank you.